Good morning. Welcome to this live stream. I'm going to be joined shortly by Han Verstraat from the OpenFaaS team, and we're going to be showing you something we created for Linode or Akamai Cloud Computing to run OpenFaaS and serverless live in production on their cloud offering. Now, whether you're watching this live now or later on our channel or on the Akamai channel, we have an active community and lots of documentation and tutorials online. So this is just the start. It's just to give you a taste of what's possible, and there's plenty more where that came from. Okay, so I'm now going to bring on Han. Good morning, Han. How are you?
Good morning, Alex. Glad to be here.
So this is your first time live streaming with me. We've
Yes.
done a lot of community calls together. We've done plenty of customer calls and things like that. This is your first live demo. Now, we're not necessarily going to have a huge audience because we only announced this about 10 minutes ago. But we've worked very hard on the tutorial here, and we've got some great Terraform that is available on GitHub we're going to be running through first. And actually, I could just put up the blog post. This is the first of two. And the first one is really focused on the infrastructure. So we start with a kind of function in mind that we want to run. This one connects to SQL. In this instance, it's Postgres. And we're doing a select, turning that into JSON and returning it to the user. So a very good place to start off. Now, there are a few reasons why you may want to run OpenFaaS on Linode instead of necessarily using a managed cloud product. And one of those reasons would be that, well, you're a Linode customer or you're Akamai Cloud customer already. And this is one of the things that's not available as a managed service right now. And so there are users there who can bring a lot of their workloads across, like object storage and databases, but the functions and services a bit they're stuck at. And so OpenFaaS gives you that portability. We also have a better developer experience in many cloud products because you can run it locally and because there is a REST API and container images used instead of zip files and various other things. Now, just as a quick disclosure, this is a sponsored video. This was commissioned, but we got to pick the content, and we do think this is a good cloud to be running OpenFaaS in. What will happen is we'll use Terraform to create a load balancer. The load balancer will load balance the Kubernetes API across 3 servers, and those servers will run K3s behind effectively a firewall or on a private VLAN. And that's very important for K3s security because the networking uses something called VXLAN, and the way it's used is very easy to snoop upon and even join that network for malicious reasons. And so we're running this in a production-ready way where that VXLAN is completely private. All of the bandwidth that's used is within the region and data center, so it's free. And we're not, as some people do, sort of when they're not aware of this, running all of that private network over the public internet and kicking up a big bandwidth bill. We can also add agents in. Agents aren't covered in our initial Terraform, but you can pick the amount of servers you want, and we show you how to add in more. And once that base infrastructure is laid down, we'll walk through how to install OpenFaaS through our Helm chart. Now, if you are not familiar with Helm, we do have an app called Arcade that can install OpenFaaS in one command. And what we'll end up with is this node balancer that was also balancing the Kubernetes API will balance port 18443 for Ingress. That Ingress will be configured with Cert Manager to obtain TLS certificates. So your gateway will have a secure endpoint. And then we'll deploy a couple of functions. And so this will all be running in the cluster by the end of the tutorial. There are a couple of things that you need to do on Linode that we found out the hard way. So we'll show you how to do that to get Ingress Nginx working properly. And then we'll put a function in place. And if we have time, we have a Grafana dashboard we want to show you and we'll just toggle from the free community version of OpenFaaS into the standard commercial edition, and we'll show you the dashboard and some of the other stuff that can be done. Okay. All right. So, Hannah, is there anything else you want to add before we get going with that?
No, I think you've covered the tutorial.
Okay. So that's part 1. And then part 2, which will be in the new year, is how once you've set up that system, you can start migrating AWS Lambda functions that even access S3 and potentially use a lot of RAM, doing things like FFmpeg with native libraries, how you can port that over to OpenFaaS and what some of the differences are. And I wrote the first tutorial and Han did the lion's share of the second one. And you can see some great detail in here. And so we'll go through that in early 2024. Okay, right. So if you've got your screen ready, I'll just take mine off. Hi, David. Thanks for joining the stream. Good to see you here. If anybody has questions as we're going along, just feel free to drop them in. And then if you're watching this later on, leave a comment and we'll reply. All right, so we see your VS Code.
Yes, so this is my terminal where I will be doing any commands that we need. And then I also have my browser with my logged in to the Akamai Cloud dashboard, where we will be able to see all the resources that we're going to create. So let me start by grabbing the Terraform that you provided with the article, so we can start to apply that. It should be all available on GitHub. So this is the repo. Let me just clone that quickly.
And I think we've made a small change to that yesterday as the Terraform versions have gone on. We changed a couple of things in there, but it's largely the same. And actually, the reason Han is running through this rather than myself is that I've still got the cluster that I created. If I look at the date of this article, I'd say my cluster's been running since early August, and I don't want to destroy it because it's been so stable for customer demos, community calls, development. And so it really has been a production cluster that I've been able to just keep updating. And I think sometimes when you're developing software, open source or otherwise, it's tempting to delete and recreate environments all the time. And this is forcing us to have some empathy with users that actually have to upgrade over time. All right, so you've got, what have we got here? We've got the main TF.
Yes, and then we've got the TF var file where we have to set some environment variables. Of course, we need an API token to be able to access the Linode services. So I will be grabbing mine shortly and adding that here, so then we can run the Terraform command to get everything up. And then there's also a variable that you can edit for the amount of servers that we want to create. By default, we set it to 3 servers. But if you want more, you can always edit it here. So let me quickly grab my API token.
Yeah, and this is obviously something we won't be sharing on the screen. The other parameter within that TFRs is just the amount of servers. And the servers are, they were known in the Kubernetes world as masters. I don't know if they're still called that, if they're called something else now. But effectively, they are the control plane. In K3s, by default, the control plane nodes can run workloads. So you could just have 3 servers and not have any agents, or every machine in your cluster could be a server. That's not an issue. An agent will obviously take up slightly less resources than a server, And one thing to bear in mind is because we're using the embedded etcd, you need something called quorum, which is you effectively need an odd number of nodes for this to be useful. So 3 nodes is perfect, 4 is useless, 5 is perfect, and so on. And that's really because of how the Raft consensus algorithm works within that. And if you're not aware of it, etcd is a key value store, and most of the components in Kubernetes are actually stateless. And so they can be restarted, moved around, new ones can be added in, and they're looking at etcd almost like a database to know what the desired state is for the cluster. Right.
Okay. So
you've got
we've
that
got in place. So
don't cat it by
of
accident.
course. I'm sorry?
Don't cat the file by accident.
Yeah, no. We'll be careful. So I've can do a Terraform plan just to show what we're going to
Do we
create.
need an init as well to download the Terraform init to
sure.
download the provider modules?
Yeah, of course.
So we worked with Akamai's plugins. It's a little bit confusing because Akamai acquired Linode. It's now called Akamai Cloud Computing. However, Linode is still used all over the place, and so you will use the terms interchangeably. I guess you could just go straight in for an apply because it does ask you if you want to apply it or not.
Yeah. Let me. So. And then we, as a var file, we specify our main TFR. So I just edited. So then it will show me what I want to create, all the resources.
Yeah,
in this
we can
case,
have a look at this while it's creating. So it takes 2-3 minutes. It's not too long.
So I will just tell it to start. So it will create a node balancer on the Akamai Cloud, and of course our 3 Linode as well, that each have.
That's the name of a VM. It's
yes.
sort of a little bit confusing, but that's actually what they're called. And we've used 4 GB RAM, dedicated vCPU, Ubuntu 22.04 as the operating system. And there is a weird thing that we had to work around, which is that the name of every Linode VM is localhost, and that doesn't work well for K3s. You need unique names, and so we use Terraform's remote exec to go in and actually set the host name to the one that we've generated. Perhaps you could show that in the Terraform.
I was going to mention, like you said, here we have 2 interfaces, one that will be public and one that's the internal VLAN for the communication. What else did you want me to show?
If you show the Terraform itself,
okay,
we'll be able to.
This is still.
Those are the remote execs running.
I
think you would less or something.
Oh, why didn't it open?
You have it in a web browser as well, don't you, or something?
Let me. Okay. Oh yeah, I can open it. It will be better to show it here. So if we go to the Terraform file.
We need to zoom in a lot. More, even more. That's perfect. Yeah, so we talked about the versions at the top. We then have a variable that comes through from the base file, which is the API token. That's how we talk to the REST API. We've got the number of servers. And so if you were to run this once and then you run it again after changing that from 3 to 5, the first 3 will remain untouched and the next 2 will get added in. We have your current SSH key will be uploaded to your account as a new key, and that will be set via the API into those servers, which is how this remote exec works later to go in and change the host name. What do we have next? We have the VMs. So if you wanted a bit more RAM, depending on what you're running, you may want more than 4 gigs. This is where you would come in and change that. So we have G6 dedicated to. If you Google that term, it shows you a whole list of other ones that you could use instead. Keep going. We then have a VLAN that's being configured. And so that's going to take the index of the server. So we've got .1 and .2 and .3 will be inputted here for each of the machines. And there's the host name CTL that gets executed over SSH, all very quick. I mean, it's probably all finished already. We then have the node balancer, and you'll see there's 3 separate ports. So 6443 is the Kubernetes API. We then have HTTP port and HTTPS, which are for Ingress Nginx. The rules for those that match on different labels. Yep, that's great. Just keep going down. And finally, the output. We may actually see the output already if you want to have a look.
Yeah, let me switch back. See.
Yeah. So this output cannot be copy and pasted into a provisioning tool. But what we can do is using Ketchup, which is an installer, K3s installer that works over SSH, use that key that we've pre-installed to build the cluster out. And you'll see from the commands we use, we'll specify an interface, which is the VLAN interface. And that will take the VLAN IP. It's very important that happens. Otherwise, the network communication could be done over the internet, which could mean that it could be attached to by a bad actor, intercepted, and all sorts of things. And then the public IP is important for in terms of ingress and being able to access that server.
Okay, so I think we can, now that we have our resources created, of course, you can also see them appear in the dashboard. So we see that all servers are running at the moment.
Yeah.
So
what about the node balancer? Because that should have 9 rules. So 3 ports times by 3 servers, and they're all down because those TCP ports are not open yet. And so
yes.
The first thing will happen is when we install K3s, 3 of them will come up. Then when we install Ingress Nginx, the next 6 will come up, and we'll see 9 out of 9 backends set up.
Okay, so let me quickly pull up the article where we have the instructions to run for the Ketchup install command and some of the So we've provisioned our servers, we've done that part. So now we will go ahead and set up the first server. So since we'll be reusing these...
We just need to zoom in a bit more than that. Even more. Yeah, that's perfect. So as I say, Ketchup is available at ketchup.dev. This is an open source tool written in Go. I started it around 2019 when I was doing a lot of tutorials for installing K3s, and I didn't want to spend 500 words going through the same repetitive commands each time. And so this just gives us a very easy way of setting that up. And then when it comes to a HA cluster, there's more parameters that are needed than a simple install. And so that's why we're using that tool here. I mean, you could use something like Ansible. It's a similar idea. It's also working over SSH. But we wrote this, we understand it really well, and we're able to customize it as we need as well.
So let me grab the channel, K3s channel, and the user that we're going to use for the SSH connection. Just enter those already.
Are you going to put this into an editor first, and then we'll run it from there?
Yeah, I can do that as well.
You could use Vim, or you could edit in a file in VS Code. It's up to you.
I will use Vim, I think, in this case. So Vim, let's create a file for the first server.
I tend to have one file and I put everything in it, and then
okay,
I can run it and rerun it. But that's fine. Keep the name. Yeah. So now we want to paste in what we had. We'll just run through the options quickly.
Okay. So
that whole block probably. Yeah. So do you want to explain the different options?
So yeah, as I already started, we have the channel. We'll be able to select the K3s channel if you change command in this variable. In this case, we're going for latest. The user, this is for the SSH connection that Ketchup will make to install K3s. So we'll be logging in as a root user. Then we need the TLS SAN. This will be the IP address of our node balancer that we've created. And then, of course, the server IP is the public IP of our first server. And then the VLAN IP will be the IP that our first server has on the VLAN.
And we have some other options there as well, don't we? So local path and merge. So when you run Ketchup normally, it will save a brand new kubeconfig that's completely independent of your main one. And that's because we see Ketchup really as a development tool as well as production. Now, in this instance, we want this cluster to be long-lived. So we're actually merging it to our normal kubeconfig, and then we can switch the contexts between different clusters on different clouds and local. And we're also putting in a name here of context, K3s OpenFaaS. And then, as I said, we have both the node IP and node external IP and the flannel interface all have to be set here. And because we prefer Ingress Nginx to traffic, we're disabling that as well. The TLS SAN IP address is handy because what it means is that there'll be a separate TLS certificate created by K3s on every server where that server will answer a call from the node balancer IP. So in our kubeconfig, we are not going to have server 1, 2, or 3 in that file. That's for HA. We're going to have the node balancer instead. And what that means is if server 3 went offline, the node balancer would take its backend away and the request could have gone to server 1 or 2. Or if we're running Ketchup kubectl commands over and over again, they may actually load balance between all 3 servers every time you hit enter. And so that's an important detail here.
Okay, so we can start by replacing these values with the ones that we've got from our Terraform output. So the IP of the node balancer. We'll also need to grab the IP of the first server, the public IP. And then this should be the same already.
Yeah, for the first one.
So we don't need to change that.
So I mean, technically, we can run. You could just run this, and then as we add the other servers in, you can keep rerunning it, and it won't destroy the cluster. It is a rerunnable operation. So we might as well give this an initial try. If you chmod the file and give it a run through. Hey, Sebastian, thanks for joining us. If you've got any questions, let us know.
Okay. So
and if you want to see more about Ketchup, it's ketchup.dev. There's the link on the screen. And in the background, we can see that you've now had that merged into your kubeconfig. So you should be able to switch into that and run the get node command. by copying and pasting those 3 commands?
Okay, so switch to the context and then taking a while for some reason.
Yeah, it is, isn't it? Did you do the export? Are you on the right?
Let me...
Have you set the context correctly?
Yeah, it should. This is displayed here as well.
I wonder if did you already have this? Perhaps.
Yeah, might have been. Yeah.
So if you edit that script and you change the name of the context, we can merge it. Should be able to merge it in again and just call it K3s live or something. Yeah, and run the script again. And so because it's already installed, what you'll see from the installer, which isn't something we've written, it's something that that Rancher provided. It just a no-op, but we've saved the context again. So can you copy and paste all 3 commands, or do you have to do them one by one?
I think I can copy and paste them all 3.
Okay. Perfect. Okay. Now, whilst we're here, try the new ketchup ready command. And this is something that we've used in CI/CD and in GitHub Actions.
I've actually never...
So it's ketchup ready, and then you can have a look at the help for it if you want. Now, just quick hello to Richard Case. Thanks for popping in. Yeah, glad that you love ketchup too. And so try the first, try that command. So ketchup ready. The kubeconfig should be your default one, and then you can put the context in as well. So ketchup ready. -- context, and you put K3s /live, I think.
Yeah.
Let's see. Enter. Right, and what that means is that because the way K3s starts and then gets ready over a period of time, it downloads images, just the command finishing doesn't mean the cluster's ready. And so we specifically wrote this, and this does the polling and will block. And it's great in CI. So you can do the install, run ketchup ready, and then as soon as that command unblocks, you're good to go and you can do what you need. So let's add cluster server 2 and 3 into your Vim file.
Yep, we'll do that. Let me be the same command twice.
That's right.
Okay. If we want them both, we'll have to.
I think that we just overwrite the variable, don't we, in the second without an export? Yeah, for the third one rather. You will need them there, but you're just going to change instead of export. You're just going to assign to it. That's right. All right, so Han's going to copy and paste in the different IP addresses. Whilst you're doing that, I'm just going to pop up for people my screen. And this is a new command. I don't know if you've seen it yet. But this is really designed for automation and is actually great for use with Terraform. what Ketchup Plan does is it allows you to provide a inventory of hosts, a bit like you might have with something like Ansible. And so we have the host name that we want to use, the IP address of the server, and by providing this, we can take everything that Hans are doing now and everything in the blog post and reduce it down to just one command. So it's Ketchup Plan, the JSON file, the user we use to connect to the servers, how many servers we want. And what this means is if you have a file with, what have we got, 5 here, we put servers 3, the first 3 IPs from that file will be created as servers. Anything extra, so the last 2 in this instance, will be joined as agents. And we can also put in extra args. So in this instance, we are disabling traffic again. Nothing against it. We just like Ingress Nginx a bit better. And then we put that into a bash file. That bash file can then be run. And if you want to tweak things, you wanted 5 servers, you run the script again, regenerate the bash file, and run it. If you want a live demo of that, and the reason that I created Ketchup Plan was actually to be able to take a big bare metal server, run loads of VMs on it at once, and then create a huge Kubernetes cluster for testing. It was actually OpenFaaS at scale. So that video is linked from the Ketchup README. All right, Hannah, are you ready?
Yes. So
I'll switch you back over. So we're back on your screen now.
Yeah. So I've added the IP addresses of the 2 remaining servers. So I think we can now run the script again. Oh, and yeah, I think it's okay.
Yeah, so you get your no-op for the first one because it's already ready. And that's a great way of getting a kubeconfig if you've lost it. You deleted it or messed up your file, is if you just run ketchup install, it will do nothing, and then it will fetch back the kubeconfig and merge it again for you. Incidentally, your node balancer now should show at least one upstream. We should see one on there that is ready.
Yes.
Yeah, that's server 1. And in a few moments, you will also see server 2 and 3. And we can see some transfer as well. And that transfer is any kubectl commands we ran. So we did kubectl get nodes. That took 17 kilobytes. And we can see that went through the public internet. When we look at the linodes, because we're using the VLAN for the internal network, we'll see that that's all going over the VLAN instead of the public internet and a network. And this, this can take a while to populate, but really we want to be using the internal network for K3s communication, not the internet. Then the users access it over the internet. All right, so I guess you could get nodes again. Is that an O wide? It's a bit hard to see sometimes, isn't it? But they're all ready. We have the internal IPs .1.2.3 and external IPs, which is perfect. So I reckon on your node balancer, you should see 3 out of 9 now.
Let's check.
It may just be taking a few seconds
might be
to get reprobed. Yeah.
2 already.
Okay, that's great. What's our next step?
They're starting to show up. So the next step would be, if you wanted to, but we're not going to do it here, you could add additional agents. Or do we want to add another agent?
I think we'll keep the 3 servers we've got, and then we'll.
Yeah.
Is it Ingress next? The Cert manager? I can't remember. Do you want to go and have a look?
Yeah. Then we can start to set up Ingress and Cert manager, because we'll need both. We'll start with Ingress Nginx, and those can also be easily installed with Arcade. So we're in the correct context. It's just
a limited edition Arcade mug. I don't know if you can see it on the autofocus. One of a kind. Printful is a great place to order swag from if you want custom t-shirt or mugs. We don't sell these anymore, so if you did want one, you can order your own. The logo for Arcade and Ketchup's on the internet. We've got them in the repos. Go over there, just pick what you want. Very good quality. All right, so you installed Ingress Nginx via the Helm chart using Arcade. So it's a normal installation. Yes. And so what did that put into our cluster?
So this deployed an Nginx Ingress controller. We can use it to get traffic to our cluster.
That's good. And there was, remember in the intro I mentioned, there was this tricky thing we ran into, that this doesn't work properly unless you edit the service and specify the external IPs. So do you want to edit that service? And we'll just refer to the blog post. And under spec, there should be an external, well, if it's not there, we need to specify external IPs. So if you go down, keep going. Let's just make sure it's not actually in there. Keep going. Right, so it's not actually the status. It looks like this would work, but we actually have to put it in the spec. And so under spec, we need external and then IPs capitalized. Right, and then we're going to put in, it's a list, and we're going to put in the node balancer IP, so the external IP that's shared across all the machines.
Okay, let me quickly get it again.
This is the thing. Sometimes you think, oh, okay, it's going to be very easy. It will take me 5 minutes to write the Terraform, and then I'll just set up the cluster. And then you run into something like this. And I think it took us a couple of days to work out what was wrong, find out how to fix it. And this makes the load balancer function properly. Got your IP?
Let me grab it from here, I think, the node balancer, so we can just copy it and paste it in here.
So what is it? 139.144.247.128. So I've just done a curl to that, and I got a not found, which is what I want. You're going to save that. And it's not for Nginx itself, it's for Cert Manager that we need to do this, because Cert Manager uses that to know what IP address to use for the HTTP challenge that we'll do in a moment for the gateway.
Okay, right. So now we need to do the same and use Arcade to install Cert Manager. So also a single command that uses the Helm chart. Okay, so that's up and running. And I think now we can move on and install OpenFaaS.
Yeah, let's go back to the tutorial, just show people where we are in it.
Yes. So we did install the servers. We checked if the nodes were available.
Yeah.
Then we
let's
installed
go to the picture just quickly, because that might be helpful. Yeah.
So we installed Ingress Nginx. We've also installed Cert Manager that we'll use later to retrieve a certificate. And now we're going to install OpenFaaS on the cluster.
I know there's a few people on here that use Raspberry Pis and have K3s installed there, or going to be doing that over Christmas. All of this tutorial will work there. Obviously, you won't use a Terraform for Raspberry Pi because they're just bare metal hosts that you already have. But the arcade commands, the Helm commands, etc. Now, we're actually going to be using Helm instead of arcade for the install because we want to show you a bit more power. So if you pop open that Helm chart README, we can go create the namespace is the first step. There's a couple of namespaces for OpenFaaS, one for the core components and one for any functions you create.
So OpenFaaS Helm chart.
So we have Helm already, and yeah, that's the first thing, getting the namespaces in.
So
there they
those have been created. Then we need to get.
Well, you will have that repo already, so we probably can skip that.
I will just do it. Yeah, it says it's already installed. And then we also
there is something that is a note there that's important, I'd say. Is there a few ways of exposing the gateway, the OpenFaaS gateway, which is how you just stop there. The best one I'd say is the first, which is cluster IP. Now, this is going to keep it completely private. Then you can add Ingress, so you can have a secure HTTPS URL to it. The load balancer, I wouldn't recommend for anybody to actually use because that will just use plain HTTP. It is just there, I think, for legacy reasons. So local installation is always cluster IP. That's the default. Then if you're going to go on the internet, it's the Ingress controller way. We're not going to use the chart to specify the Ingress. We're going to actually use an arcade app to put the Ingress on in a minute. Keep going. Okay. So there's a command we want.
So we can copy that.
Yeah.
And
this is effectively what you get when you do arcade install OpenFaaS. And I think sometimes people think, oh, it's not called Helm. Does that mean it's production ready? Well, it is just running Helm. It just makes it a bit easier for you. But when we install for customers or we ask customers to install commercial OpenFaaS, we'll say, use Helm, use a values YAML, because when we support you or you have a problem in production or the timeout isn't right, we'll ask you for the values YAML. That will help us know what you've got in the cluster, and then we can tell you what to set and what to turn on or turn off, etc. All right, so that was very quick.
Yes, it's running already. So we also get the command to retrieve the credentials, so we can log in. Of course, you cannot.
The port forwarding is just before you have Ingress Nginx working and your certificate. This is how you'd access it if you're using Kind or K3d, or even if you're running on your Raspberry Pi cluster from another machine.
And another handy thing, if I forgot the command or it's gone, how to retrieve the password, you can always run and get information from Arcade. So if the Arcade app normally displays this when it's installed OpenFaaS, but it's really handy to just get the password and then use that to log in with the FaaS CLI.
Yeah.
So we see the credentials were saved, and if we do a FaaS CLI list, of course, with no functions deployed yet, we can deploy one from the store. And we should see that now if we do a list again. So now we've got the
Here's an idea.
env
Why don't you deploy
function.
the external IP function? That'd be interesting because we should see that come back as one of the nodes in the cluster.
Is this one in the store?
Yeah.
It's there.
Now, just like you have ketchup ready, every function in OpenFaaS has a readiness state as well. And if you do facili describe external IP, that will tell you if it's ready. And it gives you the URL based upon the gateway you've configured. So that's ready. You can invoke that. Or you can curl it, let's say, via that URL. That definitely looks like one of your servers that came from. If you run it a couple more times, does it change? It probably won't change actually, because that function only has one replica. Yeah. Okay, cool. So we've got OpenFaaS installed. However, we're only accessing it over HTTP locally. And this is where we have this OpenFaaS install Ingress, OpenFaaS Ingress. And what that does, it takes a domain, a subdomain. So I guess you need to create a DNS-A record or CNAME record for your node balancer, Han, against one of your domains you own.
I will go ahead and do that. Let me see.
What are people using for their DNS? We've got 4 people tuned in. When you're doing development, is there anything anywhere you like to put your DNS records, your domains? Now Google Domains has been deprecated.
I'm using Cloudflare for mine.
Okay. A DNS can take a few minutes to propagate in the best case. In the worst case, it can take quite a bit longer. So if you tell me what the subdomain will be, I can give it a ping on my end and see if it's resolving correctly. We're just getting some static on your microphone. Did you have some foil or something that you were moving?
Yeah, I had to my wiki to sign in to Cloudflare.
Yeah.
Plastic bag.
Still getting that static from your line. Quite a lot.
You do the stream.
It might be your internet connection, Han. Sorry about the noise, everybody. Do you think it might be your YubiKey creating the distortion?
Again.
Or your internet seems to have degraded. Well, what we're doing at the moment is we're getting the IP address of the node balancer, and we're creating a DNS record for that. And then Cert Manager will use that for a HTTP 0.1 challenge. There's 2 different kinds of challenges that Cert Manager, or let's say Let's Encrypt, supports. The first one is the simplest. And when Han runs the app in a second, this is going to use HTTP requests to the Ingress controller to try and verify that it's talking to the right place. A challenge will be served up, and if it passes, we haven't used up all our rate limit, that will be issued, and the Ingress controller will reload with the secret. The other kind is a lot harder to use in practice. Once you've got it set up, there's not much to think about. But a DNS, the other one is a DNS challenge. And these are perfect because you need it for a wildcard. And wildcards are great if you're going to have, let's say, an OpenFaaS and a Grafana. You could actually just have one wildcard domain and then both of those subdomains under it. Right, so I'm going to just unmute you again, see if it's any better.
So,
no, audio's not good. Do you want to try reconnecting your headphones, or do you have an external mic to use?
I will switch my headphones, the earbud ones instead.
Yeah.
Try that.
All right. Just put your thumb up when you're ready and I'll unmute you. All right, so we have OF Live. I'm going to do a ping on this line, oflive.worldtechie.dev. And that is resolving to the node balancer for me now. And the HTTPS for that is giving me a not found and an invalid certificate, which is what I'd expect. Right, just unmuting your mic again. Your mic is not connected, it's saying. Okay, can you say something now?
Yeah, can you hear me?
That's perfect, yeah. All right, sorry about that little interruption, everybody. All right, now, Han, could you go set up the HTTP 01 challenge, the certificate, and the Ingress using the Arcade app?
Yeah, so we've installed OpenFaaS. We've got our DNSA record in place. Let's add it to a environment variable. And then we can install the OpenFaaS Ingress with Arcade.
Yeah.
So we don't need. Oh, I probably should have. Oh, should be like this.
It might just be domain.
Yeah,
okay, you're going to switch around. Yeah.
This and then this
it's
needs
OF
to be
Live,
changed
isn't
to
it?
OF
Instead of
Live.
OpenFaaS.
Yes.
Yeah.
Okay, and this should have created.
And Cert Manager originally didn't run on ARM or Raspberry Pi, so that's something that changed. I think about 2019, relatively recent. It also has some really good CRDs and custom resources, and generally there's not that many reasons to look at the logs because the CRDs are just so helpful. So let's see if we got an issuer now. It may be that it's a normal issuer, not a cluster issuer. And then you need a namespace.
Yeah. So this should be the OpenFaaS namespace.
Yeah. And that's showing is ready. That's registered for your domain with your email. So you can get an email when it's going to expire in 3 months. You got a certificate ready?
Let me.
Yeah, it's ready. Awesome. So I'm going to do a curl of that from my end and see if I Still need TLS insecure. I don't. It's all working. And then what I probably want is to go function. And then what did we deploy again? External IP.
Yes.
So I'm curling that. I'm getting a response back from that. So we now have OpenFaaS on a HA Kubernetes cluster with 3 masters or servers. We've got a node balancer where the API is getting spread across the 3 servers. We have a node balancer for this TLS communication as well that's also getting spread across all 3. And we've got a function deployed. So this is the majority of the first tutorial. And in the second one, we get really into the weeds. We take an AWS Lambda function that does video transformations triggered by S3, and we migrate it to this cluster and then show you how to monitor it. So what else we wanted to do in perhaps like the 5 or 10 minutes that we've got left is maybe just deploy a function. Now, the one in the blog post looks fine to me. It looks like it goes off and does a HTTP request to a URL. So that would be a nice simple one for us to try and deploy now.
The Python example. Yeah. Okay. So let me run through that. So we'll start by creating the function. So we'll make sure we need the Python HTTP template. So I pull that from the OpenFaaS store. So this pull down the required template, and then we can create a new function. I will first use the OpenFaaS prefix. This can be set to include the Docker registry where you want to. I will use the temporary ttl.sh.
Yeah, if anybody is not using ttl.sh and works with containers on a daily basis like we do, it's really handy. They last for 24 hours, or you can ask them to last for even less through a tag. And it means you don't fill up your cloud account or your registry with images that are just you don't need to have long term.
And then we'll use fastcli new to create a new function. And then by default, it names the stack.yaml file where we configure the function, names it the same as the function. So we'll move that. So it's the default name stack.yaml. And if we...
I often see people sort of missing that you can have multiple functions in one stack YAML, and that's really the design. Is you can have 1, you can have 2, you can have 100, and then all the commands like build, deploy, push, they all accept a filter or a regex. So if there is just 1 or 2 that you want to get to, and you don't want to redeploy everything, you can actually do that too.
So, and our you can also see the
handler requirements
the
file.
handler. Yes. Let me. So we have a handler py, and then the requirements.text where we can add additional Python modules that need to be pulled. So if we...
Yeah, it looks like we've got, what have we got? The requests module that we need to add in there.
Yes, so I can edit that already.
Now, URL lib can be used to make HTTP requests as well. I think my preference is for the requests library. It's a bit similar to Axios in Node.js.
So that's added to the requirements.text,
Okay.
and then we can take a look at the handler. So this is a default handler that you get when you create a new function using the template. So it just returns a 200 status code and a message. And we can now start editing our template with whatever we want. In this case, we'll just take the example from the blog post. Let me quickly grab that. So we can keep the handler function, and then I think this needs, okay.
So we have a bit of error handling at the top, just to make sure that a URL has been provided in the body. When we do the request, we do it with a try catch so that we can understand what went wrong, if something did go wrong. And then finally, right at the bottom, we end up returning a successful message if everything went well, the body and status code of that. So if you want to do a publish of this, I would say perhaps use the tag digest for that. And what that does is, because we use a container image, rather than using the word latest every time and confusing Kubernetes, because it's going to say, right, well, I'm already running latest. You did do a deployment. It won't necessarily know that you want a new version of the same tag. Really, we should be changing names. And tag digest looks at the text files that make up the function, calculates a hash of them, and uses that as the tag, which means that all day long you can do redeployments of this function. And as long as you've changed some text in the file, it will compute a new hash, give you a new tag. And this registry TTLSH, one downside is to it has a little bit more latency than usual ones because it's just run for development by the replicated team. Okay, cool. So that's up and running. Now do a deploy. And this time you're going to put your gateway. And I don't think you've actually logged into your gateway,
have you? Export. Yeah. So I usually like to set the environment variable for this.
Isn't it URL?
Yes. Yeah. I was hesitating for a second whether it was gateway or URL. And this should be over live.
This can also be passed as a -- gateway flag or -G for short.
And then, of course, we need to log in. Since I have to do this, we can copy the command, but I also have a shortcut in my terminal to do it with a single command. So we should be able. So this is automatically using the environment variable, so we can see the functions we deployed. It's working.
Yeah. So the port forwarding that you have running now, you could go kill that off. That won't matter. We're now accessing this over the internet. And if you had different team members, they could access it too. Or if you wanted to deploy from a GitHub action, that URL uses HTTPS plus the password that you've got means you can do that relatively securely into the community edition.
So we can now do a fastCLI deploy, and it will deploy the function to our cluster. Ping URL.
It's not ready just yet. That's because that says latest. So when you do your deploy, you need the tag SHA that we used.
Oh, yeah.
So and if anything changes in the directory during the build and the deploy, you obviously have to publish again. But I think, does that match the digest if you scroll up? A055 of what we published. Just scroll up. We don't have it anymore. Okay, it's gone history. Do another describe. Let's see. We may just be pulling the image.
Yeah, it's ready now.
All right. So you can go and invoke that then. And the way it works, I think, is just a body, a normal body. Or how does it work? Is it JSON with a... Do you want to have a look at the blog post?
In the blog post, it it accepts a URL in the body. So like this is the example. So here at Wikipedia, and then we'll just take the top lines of the return. So if we replace this by my gateway URL,
So you have a problem with that. Do you want to look at the logs maybe?
Yeah, so that's also possible with the fast CLI logs, and then we want to look at the logs for our function. Oh, and I know what's going
you missed
wrong.
An import,
I missed the imports at the top.
Okay.
Yeah,
I mean, it's handy that if all you gave someone access to was OpenFaaS and not the whole of your Kubernetes cluster, they can actually debug the functions and get the errors. Okay. So now you could do the tag that you could do the digest again, and actually,
I will do an up in this case.
Fast CLI up -- publish is something that you can do, and the reason we're using publish instead of build and push is publish can be set to do a multi-arch build, so you can actually end up with images for different kinds of machines, Raspberry Pi, x86, all together. So it's fast CLI up -- publish.
And also want to digest.
Yeah, and then tag digest. Now there is quite a cool add-on to this, and there's a separate blog post that describes how it all works, which is, let me see if I can actually find it just quickly, is you can do a watch on that. And then as the code changes, they get rebuilt and republished over and over again for you. And that is really handy if you're just in the editor and you're used to working with something like from the Node ecosystem. Change it, it's redeployed. Change it, it's redeployed, and so on.
So let's try and invoke our function again. Let's see if it's, yes, this time it returned 200 status code. And we can see
the remote body back.
Yep.
Let me just pop that up on the screen then. So, and then we'll draw everything to a close as we've just gone over that hour mark. The faster way to iterate on your OpenFaaS functions, it shows you both local run, which uses Docker to build and run your function without putting it into the cluster. That's very handy, very, very fast. We also have a go down to the bottom, the automatic rebuilds by watching the file system, and that works both for local run and for fast CLI up. So they're really handy, and just remember to use tag digest, because the problem you might run into is, well, it's the latest tag, or you haven't changed the tag between changing the container, and Kubernetes doesn't necessarily know to keep pulling that for you. All right, so if anyone's got any questions, feel free to leave them on the YouTube video or join our weekly community call every Wednesday. We'll be taking a break over Christmas from that. And then we're back in the new year, where we're going to run you through how we converted a relatively complex Python function on AWS to run on OpenFaaS. And one of the things that I wanted to make sure is that we actually included something that is a native Python module, which is FFmpeg. That's a compiled module. And we take in a video from S3. We take frames out of it at regular intervals and compile that into a preview video, which is similar to when you hover over something on YouTube and it just plays a little bit of a video. And the same code was actually used for the preview that you see on openfaas.com. Right, so it's a pretty handy function to have. Han, thank you very much for the demo.
Yeah, you're welcome.
when we come back in a new year, we'll be looking at the other blog post. And as I say, if you want to find out more, go to openfaas.com/blog. There's a couple of posts that we've done as sponsored work for Akamai. I'm still running my cluster from August. It's running great. It's pretty good value as well for money. And yeah, we'll see you again. So thank you, everybody.
Thanks, everybody.
And have a great holidays.